I just did that.
Okay, everybody.
Somehow got an A, and I was like,
Few calendar things.
yeah. Like, okay.
And then we'll jump into our lesson, okay? Okay, so first off, the multiple choice for the Unit 4 is still available to take the retake through Saturday. So if you're wanting to retake the Unit 4 multiple choice test, get your corrections in and take it by, I think Saturday actually is when I left it open till. The free response was due yesterday, and if you emailed it to me, that was just fine, because I know the upload link was being weird, so some of you emailed it to me. If you didn't email it, but you shared it with me, send me an email to let me know you shared it, because I get lots of stuff shared with me, and so it can easily get buried. So if you send me an email that way, I won't forget to look for it, okay? For Unit 5, here's where we're at. We're pretty much, today we're finishing up our learning of Unit 5. What we're learning today is about rate laws again, surprise, but just another way of finding it. So we learned on the first day to do it through data analysis of where if this doubles and this is held constant and the rate doubles, we can find the order of the reactants. The second way we learned was last time with mechanisms, right? Where a mechanism you can determine what the rate law is. Today we're going to graph some data, and from the graphs we can identify what rate order it is as well. So keep in mind that these three methods all get you to the same answer. It just is different ways of getting there. For our lab today, it's all in the computer, but I am counting it as a lab. So just be aware of that for those of you that have already used up all of your lab late passes. I'm giving you 3. I was only going to give you 2, but you know, yes, I'm feeling generous this year. So you have 3 late passes where it won't get docked, but after that third one, it gets docked significantly. So if you're out of passes, don't turn it in late. If you do still have passes, be aware of that. If you don't know how many passes you have left, or if you've used them all, after class you can ask me and I'll let you know.
Would we know if we use them?
Pretty much if you turned in the lab late and it didn't get docked,
Then you, okay.
then you used it.
Yeah.
Pretty much I just always apply them whenever it gets, because I assume you want to use them.
Yeah.
I haven't had someone says like, no, I don't want to use it yet, so yeah.
Can I sell mine?
Well, actually, I mean,
Oh, 20 smiley
My
faces.
Nigerian uncle needs money to get into the country, and I don't actually have enough money for him.
You're gonna sell your lab late passes.
wait, I'll buy them.
Wait,
Yeah,
can we?
exactly.
Wait, can we sell them for
No,
smiley
you
faces?
can't sell your.
Wait for smiley faces.
That's what I'm,
Yeah.
like 20 smiley
Maybe
faces.
to me, but not to someone else.
No, don't think about that.
Wait,
No,
so if I didn't use any, I could just give it to you and you could give
It
me
would be
some.
worth it to sell it for 20 cents.
That's what I'm
If
saying.
you turn it in late, ooh, maybe. I'll figure out that.
It's a
conversation.
win-win, because like, if I have extra, I could just help somebody else out,
So like,
and I
if you
could
lost,
get, like, clearly bang of smiley
if you were
faces.
responsible, it would obviously be worth it.
I'll be the smiley face
Huh.
bank.
I'll think about that. That's an interesting proposal.
I
Okay,
like this.
so today we're doing our computer lab after we kind of learned about some graphing things. On Friday, we're going to do a chemical lab
Let's go.
where we'll be testing, we're going to take some marble chips, okay, calcium carbonate, okay, reacting it in hydrochloric acid, and we're going to test it in various concentrations and measure how quickly the reaction goes. Once again, measuring rate. And then that will be it for Unit 5. So the Unit 5 test I'm going to open up on Friday,
Oh my gosh.
and it will stay open though all the way through the following Wednesday. So you do have it if you want to wait until you have your virtual at home day, you could take it then, but if you want to take it over the weekend, you can as well.
It opens up on Friday.
Like
It will open
Friday.
Is it on AP
Yep, like
Classroom?
in 3 days.
But it's topic.
It will be back on campus again.
Okay.
I just had to do AP Classroom because at the semester Canvas like shut down.
Oh, yeah.
So that's fine, but it'll be back on campus, so. Okay, any questions about deadlines or things like that? Okay, that is a good reminder, I'm glad you said that, Max. Because the test is coming up, that means the AP Classroom quizzes, past ones, they're open if you missed them, but they'll be closed. I think I've left them open, I guess I'll leave them open until Wednesday, because that's when you can take the test by. But after that day, then you can't go back and take those quizzes. Same thing with assignments, all of those will need to be in by that test day as well, so, okay? Okay, any other questions?
Favorite color? We have 4.
Who changes?
I know.
Right now.
Today, yellow.
Favorite food?
Yeah,
like
but
yellow
favorite
orange.
food is super difficult.
Yeah,
People
I'm
ask me
sorry.
that, it's like, you-
Okay, we're gonna,
Yellow is, it depends on the shade of yellow.
Yeah, there can be disgusting yellow or there can be
What about
pretty.
bananas?
Yeah.
Yeah, that's true.
Yeah,
Potassium
we gotta go
yellow.
back into
That's
this
good
first.
yellow, right?
Yo, remember growing
Exploding like a little mine.
okay, we gotta do a little bit faster here, because I forgot we didn't get through everything last time for you guys. Okay, here we go. So, last time we talked about mechanisms, how things can happen in more than one step, and we introduced this idea of with reaction pathways. So reaction pathways are the graphs, the roller coaster graphs. Okay, for every step, you have a separate activation energy. Everyone find where we are? Okay, so if I want to draw a two-step, and now this could be something they totally have you do is draw it yourself. Okay, once again, there's details that don't matter, but there's parts of the graph that are very significant. You have in the right proportion. So we want to show a process where the slow step is first, and then has a negative overall energy change. So the slow step means that the first hill needs to be bigger than the second hill. Okay, this would be my first step. That would be my second step. Now notice when we measure activation energy, it's from the bottom to the top of the graph. Not like from the bottom of the scale all the way to the top. Right, so since I started here, this is my distance. Okay, the negative energy change is the reason why I ended lower than I started, because this measures delta H. So if you're going to have a negative enthalpy change or a heat change, your products need to be lower than your reactants. Okay? For a smiley face, draw me a graph under these conditions. Ready, set, go. You talk to your table buddy if you want. Isaac, did I hit play?
Yes.
Oh, phew. Drop your pencil when you're done. So draw me one where the slow step is second and we have a positive energy change.
Look at that, look at that, look at that.
Okay.
It's the sound effect of awesome.
Delta H.
You know, like, it's just a cool sound. Those are two of my favorite sounds.
Okay,
That's SpongeBob sound.
if you do something like this, pretty much the key things I'm looking for is that the second hill is bigger than the first. And you should have ended higher than you started. If you did that, you can have a smiley face.
Yeah. Yo, I even dipped down at the end.
Let's go.
Now, I just want to point out something I seem to be cautious with. Okay? For a question like this one, I've seen students draw something like this, where their logic was, oh, well, look, this hill's shorter than that hill, so it's the slower step. Is it though?
No.
Yeah, because if you actually measure the hill, this one is bigger. So just, once again, notice that it's not where the peak hits, it's that distance between is the activation energy. Okay?
You've never
Now,
heard that SpongeBob
we talked about these things called catalyst, right? That's the one where I made the cloud, if you think back to our demos, okay? Right, where the cloud came out. Catalysts provide ways to speed up a reaction. Now, often what they do though is they may cause more steps to happen. But those more steps in the end are still faster than the one step in the beginning. So what happens with a graph when you throw in a catalyst can sometimes look like this. Wow.
Oh, what?
Okay, where the red line shows with a catalyst, the black line is without a catalyst.
So catalysts make it a lot faster in person, but a lot more painful in theory.
I mean, not really to us, but I guess like to the molecules, it could be.
Yeah.
No.
No, I don't think you meant
Not-
physically
Not
painful.
physically painful, like writing painful. But-
Oh, because then you have a lot more steps to write.
Yes.
Yeah, but it makes it go faster in the end. Because the whole idea is they provide different ways or collisions, and so often you get more collisions to make the process happen. But in the end, it still gets faster. So the only thing, recognize
At what
this,
point do you start to feel pain?
that changes a graph is a catalyst. Heating something up does not change the graph. It makes the molecules move faster over it, if you're visualizing it like that, but it doesn't change the actual pathway. Only a catalyst will change the pathway. Now, in your reading last time, it talked about some different types of catalysts. We're just going to kind of go over them, more so just to kind of have some understanding of how these things work. I've never seen AP type questions where they ask you about a specific type of catalyst, meaning like, tell me what type of catalyst this is. More so just understanding its effect on the activation energy is kind of the key takeaway. Okay, but we've talked about this before, that the key to a catalyst is it's not consumed in the reaction. You put it in and then it's regenerated at the end. So for a smiley face, circle the catalyst in this mechanism.
Let's go.
Circle the catalyst. Kind of review question here.
For the FRQ retake, the writing for question 3, one of the questions, I think it was the third question, was a lot. It was like the one about the tablet. And it was still, you were still asking about I minus.
It got
It was like
fixed,
CL, you know?
but for
Yeah,
some reason, like, yeah, there was a typo on it, because like I take the original and then I just tweak it right.
Yeah.
And it got fixed, but for some people, because of when they opened it, it like didn't update that it got fixed. So I'll grade the retakes with that in mind.
You updated like
Yeah, cause there's the one that was like, what's the change, like, what's the mass of I minus or whatever in the tablet? And I was like, there's none, but I think you were asking about like
Should've
CL
been CL
minus.
minus.
So I did for that.
So, and that's what I'm hoping is most people could read between of what it should have been.
Yeah,
But
and since I did it the way where I only took the questions I got wrong, so I didn't get the one before that wrong, so I just made up a
Oh,
random
that's fine.
number. That's
Yeah.
fine, okay.
Yep, because as long as I'm just checking your process, right? So yeah,
Okay.
that's fine. Okay, speaking of I minus, if you circled I minus, how does minus feel?
Oh, let's go.
It was I minus, right?
Oh, no, it's fine.
Yeah, that was funny, you brought up I minus.
Yeah.
Okay, so one type of catalyst, or one of the big things that catalysts do is this idea of binding to the reactant. Think of it as like, they talk all the time with enzymes that it's like a lock and key idea. They help hold things in place so they can react like they should. That's one type of catalyst that, once again, there's lots of different types, but one of the specific types is to kind of hold the bonding. One more specific, but it still deals with binding, and they kind of all do in some way, is there are these things that are known as acid-base catalysts by forming a covalent bond. Just to kind of give you a fun glimpse of what could come if you choose to keep studying chemistry in college and you take organic chemistry. The mechanisms we see often have like 1, 2, maybe 3 steps in them. Organic chemistry mechanisms can have like 20 different steps. It's really cool,
It's cool though.
but it is a little mind-blowing at times.
Isn't the digestive system, or additive one really long?
I would assume so.
I don't know.
It's been a
my
long
sister
time since
talked
I've written
about
that. I don't know how many steps then. But I would assume that it's quite extensive with how much it breaks down, like the food and stuff.
Wait, Google it.
But key thing here is this. Look at this, everybody. So the hydrogen right here is our catalyst. So the hydrogen attaches in the beginning to help with this crazy process, and then at the end, it comes back off at the end. Right, so once again, that's kind of the key defining part of a catalyst, is it helps it go
So
faster.
it's like a friend that helps you through a hard time.
So you're saying I can send my
I
friend.
know.
That was a nice way.
Hey,
Let's
look.
put that down.
I am
Except we don't use our friends.
Yeah, I was gonna say.
So, there's also things known as a surface catalyst, where the entire surface is used to hold them in place, depending once again on what's needed. So, but any general questions for now on catalysts? Just once again, kind of just some different types, but big takeaways I want you to know is that they're not consumed in the reaction. They lower the activation energy by helping them collide how they're supposed to. So, okay, let's take a look at our graphing data now. While I get this pulled up, just pull up this. Okay, so last thing we need to look at in this unit, once again, is a way to determine the rate law for a reaction by graphing the data. And we'll practice this in a second. I'm just kind of giving you some preview of what the graphs tell us. So depending on what type of graph you get, you can identify the order for that reactant. Once again, the three main orders we talked about are zero order, first order, and second order. Okay? Zero order is the one where it means it's not dependent, meaning you can add as much A as you want, and it's not going to make the reaction go faster. Okay, first order is the same connection, meaning if you double A, the rate doubles, or if you triple A, the rate triples, right? Same change. And then second order is like the one on the quiz, where if you double A, then the rate would quadruple. Okay? Now make a side note with these graphs here, everybody. These are for three separate experiments.
Separate.
Okay, I realize it looks a little confusing because it looks like maybe it's all the same. But these three graphs are not the same experiment. Three separate experiments. Maybe next year I should change it like A.
One of them is L and A, and one of them is 1 divided by that one.
Yeah.
So why it's significant that they're three separate experiments is, so what we're going to do today is I'm going to give you some data, some concentration, okay, measured versus time. If we take that concentration and we graph it versus time, and the graph comes out linear, so this is concentration. So if concentration versus time is a linear relationship, that tells you that A is zero order. If the natural log of A versus time, so this is the second graph you create, if this one is linear, that tells you it's first order.
What would it look like if it was zero order? Wait,
And look at this.
wait.
You're
They're
good.
all linear.
So
Well,
what?
this one's not super lit. Look, notice how like there's a bit of
So that's why I'm saying these are three separate experiments, Gavin. Is
Oh,
when
yeah.
we do this, only one will end up linear.
Okay, then what would it look like not linear? Just like,
Be like exponential.
okay, cool. Anything else is not
Yeah, but not linear.
cool.
So, good question. But yeah, that's where I pulled these graphs from your book, and then I realized side by side it's a little bit, can be a little misleading. So in our lab today, once again, only one line or one graph will show up linear. Whichever graph shows up linear identifies for you the order of that substance, if it's zero, first, or second. Now, this relationship is something we do need to memorize, because given data, you should be able to identify the order based on what the graphs would look like. So for example, this is a problem I pulled from an AP test. Okay, so it gives us an equation up there. It says, what is the reaction order for N2O5? So, notice in a sense, it's not showing us graphs, but it's showing us data. But in a sense, this would be our zero order relationship, because it's just pressure, which is proportionate to concentration. Okay, natural log means first order, and then 1/, is second order.
First order,
So how do I know it's first order when I don't see graphs, Gavin?
because it's a linear chain.
Good, so to identify a linear relationship from numbers, you're looking for constant change. Once again, this shows that it's not, so like the first one is cutting in half every time, which means it's like not changing by the same increment, right? Because this one decreased by like, so from here it went down 75, but from there to there it went down
Not.
not 75, what, 30?
Probably 38.
That's math right there.
It's just 38.5.
There's
You don't have the point
I
5
didn't
there.
really do 5, but technically it would be 30.
37.5.
7.5.
But they rounded up, so.
But change is not constant. But from here to here, we see that it's changing consistently the same every time. So since this relationship is linear, my answer is that N2O5 is first order. So this is an example because they're never going to have you graph stuff on the AP test because graphing by hand is pointless. You should never graph by hand when you're doing very accurate work. You always do it like on a computer. But you should be able to identify the consistency of the changes. Evan?
So is the first one, the pressure one, or the zero order one, is that one linear or no?
It's not. This would
Because
be
it's-
exponential.
Okay, yeah.
Yeah, because it's like cutting in half every time.
Okay, so it just has to be like a consistent number.
Yes.
Okay.
Yep. No, good clarification. Harley?
Wait, so why do we use the information in the middle and not the other two?
So in a sense, we're looking at all three. So I'm looking at all three to see which one is consistent. So this one was not a constant change, so it can't be zero order. Since this one had the constant change, it tells me it's first order. If this one were the constant change, then it would be second order. Does that make sense? So it's not like the other time where we're comparing like this, like horizontally, we're just comparing vertically and seeing which of these data sets change the same from one point to the next.
Yeah, what I'm wondering though is when it asks what the reaction order is, what like determines which one?
So whichever one ends up being linear, so this is always for first order, this set of data. So the natural log data always means first order. If it was this one, this always means second order, and this one always means zero order. Does that make sense?
Are there
Mostly.
orders
I'll show
past
you a
these
table
that-
here in a second that kind of summarizes it, but.
Are there orders past these that we don't learn, or is this just like
Yeah, and there's like, you can have like 0.5, like so you can have like half ordered. Yeah,
It
something
would be
like
very
that.
effective
Isaac?
So is the one on the right not second order, or like it would be second order if it was linear, but it's not second order?
Yes. And a good catch is only one should be linear. So if you're getting more than one linear, you're looking at something wrong. Because something can't be first order and second order. It has to only be
That's
one.
true, there's no spy.
Did that answer your question?
Yeah.
For now? Okay. And once again, we'll look at more here in a second. So this right here is the relationship that you need to have memorized for the AP test because they don't give it to you.
There
Okay,
it
so
is.
circle that on your paper, star it,
Mesmerize this.
whatever you need. Okay, but the relationship between which graph means what is the big takeaway.
There's no memorize this on our paper to circle.
Oh, well then write it in.
I'm writing it in
Mesmerize this.
Now, another cool relationship is, once we identify what order it is and we have our linear line, the slope of the line, the numerical value, will give you the value for K. So this is another way in which you can find the value for what your rate constant is. So let's just review really quick. How do I find the slope of a
Y equals mx plus
So
b.
one option is to have the mathematical equation for the line. That one won't work
Changing
for
Y,
these
changing
graphs,
X.
just because we don't have our intercepts. But that one will always work. So y minus y over x minus x, or as a lot of times they call it rise over run.
Oh.
Because you have to get up from bed before you can.
Yeah, you gotta rise before you can.
It's
That what they
Wait, that
say?
equals
No.
k?
Oh.
Wait.
It's like, is that a statement?
I mean, I'd love to see somebody try to run before they get out of bed.
Yo, it's calculus.
It could be done, but we get
Challenge accepted. Well,
Okay,
that
let
would
me
be
show you this and we'll
rising.
talk about, actually, let's do this. Pull out your formula sheet for me, everybody. I wanna talk about a few of the formulas in the analytic section, if you have it handy.
What?
I don't even know what
Your
that was.
formula sheet, pull it out.
Let's see if I still got it.
I don't know.
The thing is, my binder like is old for so long now.
It is getting to the point where you should be, like, I have this handy when you take the tests on things, cause more and more this is becoming valuable, or can be valuable for you. So flip to the kinetic section, and there's just 3 equations in that section. Okay? These first 2 equations show you, it's another way of expressing the line equation for the graph, but depending on the order. So the first one you'll notice corresponds with this one right here. Can't see on my line. Corresponding to a first order reaction, so the first one, and the second one corresponds to second order. So where this equation can come in handy is, first off, it only works if it's first order, because this is the first order equation. If it's not first order, this equation will tell you. But if the reaction is first order, what you can do is you can plug in a concentration at any time, so you pull it from your data. This is the initial concentration. T is the time that it happened, and you can also solve for K. Or if you already know what K is, this equation can help you predict 10 hours later how much you're going to have left. So you don't have to keep doing the reaction for days if it's a long one. And you can just plug in like, okay, after 10 hours, this will tell you how much you have left. Yeah, Gavin.
Our formula sheet, or at least the one I have, doesn't have K before. Am I looking at the wrong one? Right there?
I can't even see that very well. Yeah, no, it doesn't have the K before the
The
A.
A's and stuff. That's.
Oh, that's LN.
Am I at the wrong spot?
No, this isn't a K. So
Yeah, no, that's what I realized.
Oh,
after a
it's-
while. It's LN.
Oh.
when I
Oh, it's that one.
See, like,
So when I must have been my math teacher, when I learned how to, so ln, by the way, for those that don't know, is the natural log function. I can teach you about it on the side if you wanna know like what it is. For now, just know it's a mathematical function. You just push a button on your calculator. And when I learned to do it, my teacher taught me to write it in cursive. So I write ln in cursive.
Good for you.
Which is probably why it looks like.
I'm
a K.
Yeah, I thought it was a cursive K.
I never even thought, yeah, good question.
Well, that actually makes so much sense now.
So that is that.
Is that just me? Okay.
Because the
No, I
other
can
is
see it. I can see it as being a fancy looking cake, so.
Yeah,
This.
That is no way like
that's true.
Yeah, look, it's
I
almost
see.
like a K. Like if you were
I
doing a
mean,
really
maybe
weird
if I took
LN.
the second one.
Look at
I don't even remember how to write
It
it.
could totally be a K.
It's like,
Basically
it's
that.
like
Cursory.
Basically that.
Yeah, that's a cursive.
So if I'm gonna write cursive K, I'm gonna write LN.
Yeah.
So the last equation on your paper has this. Where there's one other interesting relationship, but it only applies to first order reactions. When something is a first order reaction, it has a constant change over time in the sense of what's known as a half-life. Winston, I'm gonna pick on you. Do you remember what half-lives are from last year?
Not really.
So you talk about it, and that's okay, because it's like briefly taught in general. We don't even teach it in AP to the same extent.
The amount of time it takes for it to half itself.
Yeah, so
Radioactive.
in
Let's
general
go.
chemistry, we talk about it as a radioactive sample, okay? So here's a fun example. So caffeine has a half-life of about 5 hours. What that means is if you ingest 10 milligrams of caffeine, 5 hours later you have 5 milligrams still in your body. And then 5 hours later you'd still have
So if you're planning.
You're at 2.5.
2.5, so it just continues to cut in half until it's gone.
Wait, but it can't be.
But it can't be gone, there's always.
You know that it's like if you're going halfway, you'll never get there kind of thing.
Yes, so generally in math, exponential graphs just get closer and closer and closer to zero, but they never hit the line, right?
Yeah.
In chemistry, because we're dealing with physical, tangible things, it can get to a point where you're down to a single caffeine molecule,
And you're
and
like,
then it's gone.
it's gone, you're done.
Wait, so then I could get there because it's physical.
Because you're not just dealing with numbers,
Would it also
right?
be possible for like the caffeine to all be gone like super fast just by chance?
Captain America, maybe. He has a great metabolism.
He might speed up the half-life of
Then you
caffeine.
can't get drunk.
Yeah, he can't get drunk at somebody.
So, but this only applies for first orders that they have this constant change. So when we look at a graph, another way to identify first order is if you notice an exponential decline, it also tells you it's first order when you're just comparing concentration versus time. And then when it is first order, you can take that half-life value and also find your numerical value for K. Once again, it's very unique to only first order reactions. Second order, zero order don't have that constant half-life. Now what we mean by constant half-life is something like this, okay? Where in this problem, in the first trial, they started with 300, okay, and they found that it had a half-life of 100 seconds. They increased the amount, but the half-life stayed the same. That's what supports that it must be first order. If it was second order or zero order, changing your initial amount would influence that time. The only thing that will influence is temperature here. So this is just kind of a snapshot of an AP type question where this concept comes in, where if you're given half-life data, so T of 1/2 means half-life, by the way, if you want to make a note of that.
Cool.
Okay, if you're given half-life data and half-life stays constant, your brain should say, oh, that's a first order reaction.
Yeah, but it does change.
Only with
Only with
temperature.
temperature.
Oh, that's right. That's right.
But the other things didn't influence it, so.
So that makes it first order. If the half-life stays the same.
Yeah, so.
Okay.
Okay, any other general questions for now?
General. Did I already ask you if you can do a standing backflip?
Yeah, not.
I asked most people that actually.
Oh.
Yeah, you asked them that, I think.
That's right. That's it. No. Can
Ready?
you know? Yeah?
Yeah.
I was like,
Yeah,
oh,
it's so disappointing.
No way.
You know, my seminary teacher, he's like, yeah, I actually was an acrobat or whatever for a while. And he's like, I'll do a backflip. Never did a backflip. I'm so disappointed in him.
I'd go back and
Oh.
ask them again.
He's like, I
Okay,
throw my back.
log into your laptops, everybody, and let's make some graphs. If you don't have one, find one nearby.
Wait, what are we looking? Oh,
Log into your laptops, everybody.
oh wait, do we have the lab? Oh, yeah.
We're doing our computer lab.
Forgot about
That's funny.
You two want to just review it, let's sit back, and then if you see someone who's not on the case, yeah, kind of like last time.
Come on.
Okay, get on the computers, everybody. And then while you're getting that out, go to your assignment packet. The lab paper's in there. It's called Graphical Methods for Determining Reaction Order and Rate Constants.
Sounds fun.
Whew.
Oh, is it in the hole?
I'm gonna hopefully teach you some cool computer tricks. Maybe you already know them, but
It's in the
homework
assignment.
packet.
Okay.
Very last page in the homework
We
packet.
love
Pull
it.
that out.
Look at us.
I love homework.
You need to stop playing games, Landon. You've been playing games this whole class. I'm joking. Of course I'm joking, Rich. He's been paying attention.
I think we got 5 out of 6.
No, we got 6 out of 6. You weren't paying attention.
I know.
We
But that's
say
the
my
bonus
point.
question.
Yeah, what do you mean?
That's the bonus question.
Okay, pull out your lab paper, you're gonna need that too. In the homework packet, yep. And then you want to open, once you get logged in, open Google Sheets, everybody.
Wow. Stone.
I love Google Sheets.
Wait, you can change the name with classes?
No,
I actually AP chemistry stuff.
I
You can change your name for your classes.
Yeah, look. See, so in math is called mom. We'll have to do computer stuff, book class, all sorts of stuff.
That's funny. What would be the like, why would kids do that? Like, what's the purpose of letting a student change their?
Honestly,
You can also change the color.
well, I do that one. You can change the
Well, colors are obviously important, so. Okay, here's how this is gonna work, ready? Give me your eyes this way for a second, everybody. Hands off for a sec, pause what you're doing, hands off, hands up, eyes this way.
Hands up.
Okay, I'm going to show you what you're going to be doing with a different set of data. So the data you're using is the one on your paper. I'm using this other data I came up with.
So not copy.
So you're gonna follow my patterns, but you need to plug in your own numbers to start with. Okay, so let's preface what's happening in this lab. Okay, or in a sense, I did the lab, I gathered this data. We are now going to analyze the data to identify what question 1 says down at the bottom. Look at question 1, what's our goal?
What's the order of the reaction?
So we want to know what is the order for N2O5 based on this data.
We want order.
Okay, so first thing you need to do is you need to make 2 columns, one for time and one for concentration. It's backwards on your paper, but it works better to put time first. Okay, and you need to type in this into your computer. Step 1.
You're in Google.
I'm in the
Oh,
wrong.
yeah.
Oh,
Okay.
we're
Just need to
going
get on
to
Google.
Google. Oh, okay, I was like.
That was a good place to go.
Now, fun
I'm
computer
confused.
hack thing. Okay, if you ever have a pattern, so your time's in a pattern, right? So your time's at 0, 200, 400. Everyone watch this, ready? It's magical. So if you ever have a pattern of numbers on Google Sheets or Excel or whatever, start your pattern, highlight your pattern, grab this magic little blue square, whoops,
And then it will continue the pattern.
and then it will continue the pattern for you.
That's magical.
Oh.
Wait, I want to bold this.
200,
Time.
400.
That
Think
sounds
of the
like
whole
an-
thing. Wait, I
Okay,
highlight
wait,
it and
so
then I
remember
drag.
down
Then you grab that button.
No, you're writing what's on your
Oh,
left.
And then you drag that.
But in a sense, we're gonna do the same thing. I just don't wanna like project the answers in front of you.
Yes,
It
okay.
just seems like
Wait. Oh,
too
Are we
easy.
supposed to do time and concentration or the two
Oh, wait,
ones
I
right
started
here?
Time and concentration is what we're starting with.
It's, oh wait, time. 0.
Should I, wait, and then we put the 1 point.
Yeah, you'll have to fill that in by hand.
Oh,
This one.
Oh, man.
Yeah, sorry, there's not a pattern to the concentration, so you can't autofill that.
There's a pattern. Oh,
Ah, I literally just typed 1.00 and then the autocorrect.
I've tried that before. If I'm not sure if there's a pattern, I'll like highlight and see if it'll do anything.
Dude, that's a hacker strategy.
Are you at?
0.78.
I never picked up our quizzes.
Oh, the quiz, the quiz. Where did I put the quiz?
You know what's really funny for the
Do you have the quiz?
No.
What?
It's over there. Yeah, it's over there.
It's over there. Oh, okay, good.
So I was on a computer and I got this
Yeah,
warning, it's like,
there.
your
Okay.
subscription to this service will end
There's a-
in like
Right there. That's what you're copying.
1,400,862 days. And so I did the math and I'm like, yeah, that's
I'm cracked at
10,000
typing.
years from now.
Of course you did the math. This is-
4,
You're
3.
great, 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 great.
Okay, get that concentration in so we can make some graphs.
1, 3.
Only they had renewed your subscription.
Next one's I'll speak like.
Okay. What should I title it? Oh, graphing lab. Graphing.
Okay, from your guys' view behind me, are most ready?
Oh crap, I'm missing a number.
Most start?
Oh,
Just a little bit more rest.
Why did I
There
go
we
like
go.
at the center? Just drag it.
Here, copy it.
Oh.
Okay, ready?
I did two.
We're done now.
Alright.
So really close.
You really,
We there yet?
you a real
We get there
genius.
when we get there.
Let's go.
That was an incredible.
I know.
Really? Thank you.
Man.
Oh.
Okay, here's the next step, ready? Eyes up front.
Oh wait.
So what we're doing, right, is we need 3 graphs. This is our first one. So to make your graph, you're gonna highlight your 2 columns of data. Okay? Go to Insert, Chart.
Which chart?
Insert.
Now what are we looking for with our graphs?
Linear.
Yeah.
Oh.
So is our first graph linear?
No.
Which tells us what?
It's big.
No.
Oh, there it is.
What
That's
order is
cool.
it not, I guess?
It's
It's
not.
not
It's
zero.
zero order.
It's not
Not
zero.
zero order.
Not zero.
So concentration versus time would be linear if it's 0 order. Okay? Okay, now we're going to calculate the natural log of our concentrations. Okay? So we need another column for time. I'm gonna copy my time over or just retype it, however you wanna do it. Okay? And now I'm gonna compare the natural log of my concentration versus time.
Wait,
Do I need to keep the chart?
So just copy.
yeah.
Yeah.
Um,
So in the end, we want all 3 graphs. Yeah, Evan?
I was.
So, will we have to like do this on an AP test? Okay.
No.
good. So
They might show you graphs and you have to analyze them, but you're not
Okay.
gonna have to make
This
them.
is just okay. I was like, oh.
Okay, now what you have 2 options here. You could take out your calculator, type in natural log of, for me I type in this, 0.01, hit equals, and then that would be the answer that goes here.
Dude.
And then you would do that for everyone.
But there's
But-
a trick.
Google Sheets is a ginormous calculator and does all of it for you.
Oh.
So here's how we're gonna do it. Ready?
Nice. Where's
No.
the sheet?
Okay,
It's
hit
a whole
equals.
sheet.
Because that tells you want it to do a mathematical function.
Oh, that's nice.
Okay, type in ln, put a parenthesis, and then don't type the number, click on the cell of what you want it to calculate for.
Oh.
Okay, and then hit close parentheses, enter.
What? Oh, autofill.
Then you
Oh.
can autofill all the way down.
Fascinating.
So-
It's mystical and
Wait, it says number. It says hashtag
Oh,
number.
yeah, I got 0, 0.
Why does it
But
say
that's
hashtag
epic.
number?
Wait, this is fascinating.
So if you ever have to do the same calculation like a bunch of times, but with different numbers, this is the fastest way to do it.
Wait.
Oh, yo, you're ahead of the chart.
I'm so
You-
Mine
And then make a
says-
chart.
This is a weird looking chart.
Is it linear?
Yeah.
Mine's linear. You're broken.
No, mine's broken.
You're broken.
Mine's linear.
Why is mine saying?
Okay, so we're taking the natural log of concentration, so we have that cell that has 1.
Where did it go?
Yeah, mine's linear.
Okay, wait.
There we go.
Mine.
I changed it from 0, 0 to 0.
I don't remember this probably. Mine just says
Grab your
hashtag
little
number.
box, yep, and drag it all the way in there. And then you just copy your timer. Okay, everyone doing okay?
Yeah, I thought auto.
And then once you make your second graph, you can then do your third one.
I get
Well,
it.
this one's linear, so I know what it is.
Yeah, but I want you to make a third one.
Okay.
You don't get the
Thank you.
privilege of that.
Okay, so for the third one, whoops, same idea.
I'm trying to. I messed up.
Except this one is 1 divided by
Wait,
concentration.
so.
You just highlight those 2. Just.
And autofill, yeah.
Equals 1 divided by, and then just I click on this cell.
Wait,
So
what
now use grab
is
that.
going on
And
right
then just grab that.
now? Uh-oh.
So in the end, you should have 3 sets of data and 3 graphs on your paper.
I'm so just trying to figure out.
Oh.
How long does it take you? Let's take it again.
And then you grab that. It's supposed to be that, the 0, 0.
Wait, so then how do
Like-
you,
So put that, the cell right there, and then grab that.
Yeah.
how do you add the concentration in for this?
So,
Okay.
so we're doing a mathematical function of natural log of the concentration. So type ln, and then parentheses, and then click on the cell with your mouse. Yep, and then close the parentheses.
Alright.
And
Whoa.
And then go on the 0, and this little blue button square is always the autofill.
What's the equation you're supposed to
And
do?
so what the computer does automatically is it just compares divided by.
Oh, wait.
Does that make
is this
sense?
one
Yeah. Okay.
linear?
And I didn't get linear.
So, yeah, so go back up to that first one, so where it says number, that means something's wrong with your equation.
Okay.
Natural log of,
So ln.
oh, I think you clicked, so go back up so you can change it. I think you clicked on the wrong cell.
Oh, okay.
So we wanna do it for the way box.
Equals,
The concentration.
Oh.
Close your parentheses,
Do the equals, right?
and then hit
So
enter,
equals.
and then do your autofill, see if that turns your graph
is that the
linear.
bell? Oh.
Yeah.
So click on your 0 box, go to the little square, drag it down. There it is. That looks much better. Okay, it's Google Sheets, so it'll just save automatically to your drive.
That's
What's the name supposed to be for these?
No, that's, oh, if it doesn't bring up the thing, you just, the little blue box. You grab a little square.
I think it's
Sometimes it will prompt you, like, do you want to autofill, but if it doesn't, you can just go to the square.
time and then time.
Just don't forget to log out of the laptop before you leave.
So then what we get, what we just,
So then you'll use your graphs to answer the questions.
do we have to fill this first? I don't know.
No, because you're gonna share your graphs with me and they're on there. Where?
Can we just,
Oh, except there's something missing on the back side, but I just remembered that. Yes, ma'am.
So are we gonna have like Google Sheets on the test?
1 divided by.
I think she said that.
This is the exact same as the back side, everybody. It just has a chart that wasn't there before. Now let's go grab it. It should be in the printer, like the front. Yeah, I think I left it. So this is the back side. The back side you have is just missing something. It's missing that big chart at the top.
Yep.
I would put the plan
Put it there.
Well, what is this?
it's something we need, it's the.
So we're supposed to do this at home?
Wait, don't we have the blue paper as the last?
Yes.
I know, she said it didn't like.
Yeah, this chart isn't on your blue paper.
Oh, okay.
So you can still answer it on the blue paper, but you need this chart.
Okay.
So.
I just wanted to let you know I won't be here next time to listen to that.
Oh,
So
fun.
fun.
So fun. Okay, good to know. Thanks, Carly.
So I was looking at the FRQ and I hadn't had time to go over it until yesterday, and the last 3 questions of question 3, like D, E, and F,
Uh-huh.
it